Have you ever looked up at the stars and wished you could just go there? What if the fastest way to another galaxy isn't a spaceship, but a tear in the fabric of reality itself? Join us as we explore the captivating and sometimes terrifying science behind wormholes and their potential to redefine our cosmic journey. Chapter 1: Cosmic Dreams, the Ultimate Shortcut. Dr. Reese Thorne, an astrophysicist whose life had been a perpetual gaze upwards, often found himself lost in that very question. From his childhood bedroom window, where constellations were his first friends, to the gleaming observatories where he now spent his nights, the sheer, unyielding distance of the cosmos had always been both his greatest inspiration and his most profound frustration. Light, the fastest traveler we knew, still took years, decades, millennia to bridge the gaps between even our closest stellar neighbors. A journey to Andromeda, our galactic twin, was a 2.5 million year endeavor at light speed, an eternity for a species whose lifespan barely grazed a century. Humanity, in its boundless ambition, had always dreamed of transcending these cosmic speed limits. We built faster rockets, theorized about warp drives, and even dared to whisper about folding space. But it was the wormhole, a concept born from the very equations that described the universe, that truly captured the collective imagination, a shortcut, a cosmic bypass, a tear in the fabric of reality itself, connecting to distant points in spacetime as if they were mere inches apart. For Reese, the wormhole wasn't just a theoretical construct. It was the key to unlocking humanity's destiny among the stars. It was the answer to the yearning in every human heart that had ever looked up and felt the pull of the unknown. The universe was vast, yes, but what if its immensity was merely an illusion, a trick of perception that could be bypassed with the right understanding? What if the ultimate cosmic shortcut wasn't a fantasy, but a future reality waiting to be discovered, understood, and perhaps one day traversed? The journey to find out, Reese knew, would be the greatest adventure humanity had ever embarked upon. Chapter 2: Wormhole Basics. More than just a hole to truly grasp the allure of the wormhole, Reese often found himself returning to the foundational texts, the elegant equations that first hinted at their existence. A wormhole, at its most fundamental, isn't just a hole in space, but a theoretical passage through spacetime itself. Imagine a sheet of paper representing our universe. If you want to get from one side to the other, you could travel across its surface. But what if you folded the paper, bringing to distant points together, and then poked a hole through both layers? That hole, that shortcut, is analogous to a wormhole. The concept first emerged from the brilliant minds of Albert Einstein and Nathan-Rosen in 1935, giving rise to what became known as Einstein-Rosen bridges. These weren't initially conceived as shortcuts for space travel, but rather as mathematical curiosities, solutions to the equations of general relativity that described a connection between two different regions of space-time. They were, in essence, theoretical tunnels. However, the initial models of Einstein-Rosen bridges presented a significant problem. They were inherently unstable and non-traversable. Any attempt to pass through them would cause them to collapse. Almost instantaneously, it was like trying to step through a doorway that slammed shut the moment you approached it. For decades, wormholes remained largely in the realm of theoretical physics, a fascinating but ultimately impractical concept. Scientists grappled with the question of how to keep these cosmic tunnels open, how to make them stable enough for anything, even light, to pass through. The answer, they soon realized, lay in something even more exotic than the wormholes themselves, a peculiar form of matter with properties unlike anything we encounter in our everyday lives. Chapter 3: Building the Bridge. Exotic matter and instability, elusive ingredient for a stable, traversable wormhole. Reese knew was exotic matter. Not exotic in the sense of being rare or unusual, but exotic in its fundamental properties. Specifically, it needed to possess negative energy density. In our everyday experience, all matter and energy have positive mass and energy, gravity. as we understand it, is always attractive, but exotic matter, with its negative energy, would behave in a truly bizarre way. It would exert a repulsive gravitational force. This repulsive force is precisely what would be needed to prop open the throat of a wormhole, preventing its immediate collapse. The theoretical implications were staggering, but the practical challenges were even more so. The amount of negative energy required to create and sustain a wormhole large enough for a spaceship, let alone a human, was astronomical. It would be equivalent to the energy output of entire stars or even galaxies compressed into a tiny region of space. Furthermore, the very existence of exotic matter with negative energy is still a subject of intense debate and theoretical speculation. While quantum mechanics allows for fleeting instances of negative energy in certain vacuum states like the Casimir effect, generating it in the quantities needed for a wormhole remains firmly in the realm of science fiction. Despite these monumental hurdles, the scientific community, including Rees, continued to explore the theoretical frameworks. Could there be a loophole? A way to manipulate spacetime on a quantum level that didn't require such impossible amounts of exotic matter. The current consensus was sobering. While wormholes were mathematically permissible, their construction and stabilization were beyond our current understanding of physics and technology. Yet, the dream persisted. The idea of a cosmic shortcut was too powerful, too transformative, to simply abandon. For Rees, every new paper, every subtle shift in theoretical understanding was a step closer to bridging the gap between the impossible and the inevitable. Chapter 4. The Journey, Travel Through the Fabric of Spacetime. For a moment that the monumental challenges of exotic matter and energy requirements were overcome and a stable, traversable wormhole was finally a reality, what would the journey through such a cosmic shortcut actually entail? Rees often pondered this not just as a physicist, but as a human being. Would it be a serene passage through a tunnel of light, or a terrifying ordeal that pushed the limits of human endurance? The most immediate concern, and perhaps the most visceral, was the phenomenon known as spaghettification. This occurs when the gravitational pull on an object is significantly stronger at one end than the other, stretching it out like a noodle. Near a black hole, this force is so immense it would tear a human apart. For a wormhole, the key to avoiding this gruesome fate lies in the stability and geometry of its throat. A truly traversable wormhole would need to have a very wide and gentle entrance and exit, minimizing tidal forces to allow for a smooth, survivable passage. The experience, Rees theorized, might be akin to passing through a shimmering, iridescent tunnel where the light from the two connected regions of spacetime would merge and distort in mind-bending ways. Beyond the physical dangers, the implications for causality and time travel were equally profound and far more unsettling. If a wormhole connected 2 points in spacetime, and one of those points was in the past relative to the other, then traversing the wormhole could, theoretically, allow for travel into the past. This immediately raised a host of paradoxes. The grandfather paradox, where one could go back in time and prevent their own existence, or the information paradox, where information could be sent back in time, creating a causal loop. Most physicists, Rees included, believed that any physical mechanism allowing for time travel would inherently prevent such paradoxes, perhaps by the very laws of physics themselves. Maybe the wormhole would only allow travel to a point in the past that had already occurred, or perhaps the act of traversing it would create a new, parallel timeline. The journey through a wormhole, therefore, wouldn't just be a physical transit across space, but a philosophical one, forcing humanity to confront the very nature of time and existence. Chapter 5. Beyond the Shortcut, Implications for Humanity. If wormholes were to become a reality, their impact on humanity would be nothing short of revolutionary. The vast, seemingly insurmountable distances that currently define our cosmic isolation would vanish. Interstellar colonization, once a distant dream confined to science fiction, would become a tangible possibility. New worlds, rich with resources and ripe for exploration, would be within reach. Humanity, no longer confined to a single planet or even a single star system, could spread across the galaxy, ensuring the long-term survival and flourishing of our species. Resource acquisition would be transformed. Asteroids and distant systems, once inaccessible, could become mines for rare elements. Planets with abundant water or unique atmospheric compositions could provide vital resources for burgeoning off-world colonies. The economic and technological boom that would follow such an expansion is almost unimaginable, ushering in a new era of prosperity and innovation. However, such profound power would also bring with it equally profound ethical dilemmas and societal shifts. Who would control these cosmic shortcuts? Would access be equitable, or would it exacerbate existing inequalities? The potential for exploitation of new worlds and their potential inhabitants, if any, would be immense. The very definition of humanity might change as we encounter new environments and perhaps new forms of life. The concept of national borders would become meaningless in a galaxy-spanning civilization, forcing a re-evaluation of governance, law, and identity. Despite the immense challenges, the theoretical physics still to be fully understood, the engineering feats yet to be conceived, the ethical landscapes yet to be navigated, the scientific pursuit of wormholes continues. For Aris Thorne and for countless others, the wormhole remains a captivating possibility, a beacon of hope in the vast darkness of space. It represents not just a shortcut to distant stars, but a shortcut to a future where humanity's potential is truly unleashed, where the cosmic dreams of our ancestors finally become our reality. The journey is far from over, but the destination, a universe within our grasp, is a powerful motivator for the ongoing quest for knowledge and exploration.